Okay. Hello. Hello again. Welcome to this part 35 of me making a WebAssembly interpreter in Ruby. I'm trying to have fun. That's mainly why I'm doing this. I want to demystify WebAssembly for myself, maybe for you. And I want to share how I'm working on this interminable project. Like I said, the main point of this, keep reminding myself, is to have fun. I want to write code that's correct. I want to write code that's clear. I'm doing it all in pure Ruby. I'm trying to do it without any dependencies. That's the deal. Before I get stuck in, I'm going to do my usual brief retrospective of last time. So I suppose the major thing to say is that in a way, it's kind of done. Done. Imagine. I mean, it's not really done, but I've got all 90 of the sort of core tests, the test scripts are passing, and there's, several asterisks on that, various caveats apply, but yeah, it feels like a significant milestone. Yeah, it's actually come a little bit sooner than I expected. I mean, it's obviously taken a really long time to get here, but yeah, it wasn't until Chris Zeta sort of encouraged me to try running the rest of the tests and see how many of them were passing that I realized how close I was to being done with it. And the last stream was a bit of a slog. Yeah, some of the test scripts turned out to be much harder to get working than I was expecting. But nonetheless, it was still, still pretty exciting to hit that milestone. Hello, Chris. Welcome. Chris says, I've been thinking about your slow test dilemma. I think using something like GNU Parallel would make it easy to run lots of tests at the same time. Maybe xargs could also be used. That's a good idea. Yeah, I mean, the tests are certainly independent of each other. There's no reason why, why they all need to run in serial. I could run them in parallel. I probably have to think a little bit about how to, how to like interleave the output. But yeah, that's an interesting idea. Maybe I should have a look at that. I will think about that. Thank you, Chris. Yeah, maybe that's something to look at this time. But anyway, yeah, as I was saying, sort of finished, except not. But like, this is step 0 of being finished, right? Is sort of having implemented all of the main instructions, which I think I've done, passing all of those assert return assertions, which I think I've done. Yeah, feels good. I'm happy about that. Obviously the question is what next? Like I said, unfortunately, I'm not really done. There's still a long way to go before I've got anything, I was going to say anything worthwhile, but like anything even vaguely usable. Even ignoring the fact that I haven't implemented the SIMD instructions, which, well, I'm not sure if they're optional. Maybe they're not optional. I mean, the WebAssembly 2 specification is still in draft, but I suppose they're probably not optional now. I think maybe they are mandatory for WebAssembly 2. So WebAssembly version 2.0. So maybe that's something I should think about. But beyond that, I've got a few ideas about sort of where to go, what I could do next. I mean, there are 3 big barriers to progress at the moment, as far as I can see. One of them is that I haven't even thought about supporting the .wasm binary format. So far I can only, all the tests are written in sort of the text format. WebAssembly modules in that format are in like .wat files. And I've got a parser for that format, and I've got an evaluator for the abstract syntax tree that format produces. Haven't thought about writing a parser for the binary format and what the implications might be, what changes I might need to make to the abstract syntax tree to support that. So that's one problem. WebAssembly modules in reality are distributed as WASM files, binary. They're not typically distributed as plain text files, so can't actually run any real world WebAssembly. The second barrier is that there's no API at the moment to actually run a WebAssembly module from Ruby. Like at the moment, all I've done is a test runner. There's not any kind of, there's no class that you can instantiate or no method that you can call to say, here's some WebAssembly code that I want to, here's the source of a WebAssembly module that I want to be able to use from Ruby. And I think we would need that if we wanted anyone to be able to actually run WebAssembly with it. And the third sort of major barrier is that the code is in a write state. Like it's an absolute mess at the moment because I've been more or less, I have occasionally sat back and done a little bit of refactoring, but sort of for the sake of my own motivation and the sort of the forward momentum of the project, I've just been barreling through, in just sort of shameless green mode for 4 months, and the effect of that on the code quality is fairly predictable. So stuff is all over the place. Whether that's a problem or not probably depends on your perspective. But I mean, the first two things, the lack of support for the binary format and the lack of an API for actually executing WebAssembly from Ruby, are, I would say, major blockers to this project being usable for anything at all. Like at the moment, it does nothing. You can't use it for anything apart from to make some green dots appear on the screen, which feels a little bit underwhelming given the amount of effort I've put into it. So I think I have to fix those. The thing about the code being a huge mess is, I think, a blocker to it being useful for anyone to refer to, for anyone to read and understand, anyone who's curious about how WebAssembly works or even curious about how to write an interpreter in Ruby. At the moment, I think the code is in too much of a mess for it to be useful for that purpose. So I think all three of those things are important for me to work on. I just don't really know what to begin with. And I think in this stream, I'm going to think a bit about what direction to pick. But hopefully, I want to start making progress on at least one of those three things, if not all three. The last thing I wanted to say in the retro is that I'm conscious that in the last stream, I was very sloppy. I made several silly mistakes. Part of that was definitely that I was very tired. Last time I streamed, I hadn't had enough sleep, and that had a sort of, that just had an unfortunate knock-on effect on like how clearly I was thinking and how, disciplined I was being in what I was doing. So that was unfortunate. This time I've had a bit more sleep, so hopefully I'll be a little bit more capable. But it's not just that. I was also legitimately careless about running the tests frequently enough and paying attention to their results. So, I think the main contributor to that problem is that they do keep getting slower, and now it takes too long to run them. So that feedback loop is getting broken because I just can't be bothered to wait 45 seconds or whatever it is for the test to run. And as Chris already suggested, maybe running the test in parallel would be good. Chris says, I know Parallel will handle output for you, so it's not interleaved. Okay, great. So maybe I could try to address the test speed stuff today too, as a sort of an insurance policy against future sloppiness. So I think that's all I wanted to say for now. Maybe we can get stuck into actually making some progress on stuff. I was just going to say there was one thing, I didn't put it in the retro, but just for the sake of completeness, I will say I did make a couple more minor contributions to the WebAssembly specification. So two things. One, I sort of contributed three things. The first one, I mean, maybe I'll go through them in order because maybe they're interesting to different people for different reasons. This first one, there was this pull request that was opened in 2018 2018 is what I would normally say. I don't know why I said 2018. This was open in 2018, and then it kind of rumbled on for ages, and it was merged 4 days ago. However, I hadn't thought about this before, but in the intervening time, the default branch of the WebAssembly spec repo changed from master to main. But when the person who finally merged this pressed the merge button, it merged it into the master branch, and they didn't notice that had happened. So when I was looking around the spec repo to make the change that I'm about to show you in a different PR, I noticed this, and so I sort of reopened this pull request. It's exactly the same commits, but just merging them into main. So that's good. Those have been merged in now. You can see I'll live delete that branch. So yeah, that was one very small interaction, was just like janitoring on the WebAssembly specification. These other two, maybe this second one is a little bit more useful. So this was a change. This was a change I noticed. Last time I noticed that this had been merged. So this was a change to, this was one of the things that caused me problems when I was working on linking.wast, is that there was a chunk of code here that was using this v128 type, which is a SIMD type, and this SIMD const instruction, sort of vector instruction. And I was surprised to see this, because there's a whole subdirectory called SIMD that's got all of the tests for anything vector related. So I was surprised that I had to deal with this. So I just left a comment on here saying, like, this was surprising. I thought this would be in the SIMD directory. And surprisingly, the editor of the specification moved this out of the linking.wast into a dedicated SIMD test in the SIMD directory. So that's moved now, and yeah, this has also been merged in. So that's good. And actually, I added to my to-do list here, like, I did add a sort of fairly half-hearted, what's it, v128 probably. Oh yes, here we go. So yeah, there's a sort of half-hearted implementation of this single vector instruction that has to be in this specific format just to make that test succeed. But I'm not going to be running that test anymore, so you know, I think it might be better to just back out of that and not have this kind of now unused code in the interpreter. And then when I actually want to implement SIMD instructions, I can put that back in and actually implement it properly. So that was good. And finally, I noticed, I can't remember whether I said this out loud, but while I was working on this last time, I noticed that there was a mistake in the spec. Where is it? Oh, sorry, I keep forgetting that you have to go here. So there was, oh, well, look, it's been fixed now because this PR was merged. But there was a problem where the table.grow here had been copied, as best I could tell, from memory.grow, which is almost the same. Yeah, Chris is saying moving tests out of the spec is a novel way to make your suite faster. Chris, you do not underestimate my dedication to making these tests go faster. If I have to harangue the editor of the WebAssembly specification to move all of the tests out of those files so that they run instantly, then I will do it. I will stop at nothing to make this go faster. Where is memory.grow? Okay. So you can see memory.grow. In the sort of operational semantics here, this little reduction rule, there's the sort of the success case and the failure case, right? So there's this success case when you grow the memory and you just give it a constant by how much, you know, n is how much you want to grow the memory by, like the delta. And then there are all these side conditions about, like, basically, do you have room for that additional memory? And then there's a failure case here that says, well, if you don't have enough room, then you have to return -1 to show that it's a failure. And I think the table instructions for table.grow, these had just been sort of copied from that essentially. And when it was copied, the difference between memory.grow and table.grow is that table.grow takes this additional value on the stack that's called val here, that is like what the initial contents of those new table entries is going to be. And when this got copied, the failure case here didn't have val in it. So I remember last time looking at this and thinking like, well, it's a mistake that it didn't have val here, because that corresponds to not having removed this value from the stack. Like if you don't mention it here, it's like that value is left on the stack afterwards, and that's not correct. So I just made a little change here and added the value on. But yeah, as you can see, this has also been merged. So now the spec is correct in that place. So that was a bit of a digression, but I just wanted to, that was, some WebAssembly adjacent stuff that I did since last time, which I thought I would just mention. Oh, hi. That's very kind. You rock. Okay, well, I'll take that. Thank you very much. So, yes. Anyway, so some stuff to do. Oh, yes. This is very crucial. For several sessions, I've been complaining about having some kind of weird off-by-1 error. And this troubled me sufficiently that I decided to get to the bottom of it. And I did get to the bottom of it somehow. When I was putting together my list of all of the tests, I forgot one. And that one is ref_null.wast. Now, that's not terribly surprising because, well, firstly, because I was bound to make some kind of silly mistake. But like, there are a few very similar ones here. And I think probably when I was eyeballing this, in my brain, these two had sort of become the same file. But this nicely explains why my count was off by 1, because I just missed this ref is null. Sorry. Ref null is the one that I missed. Okay. So I think, well, I hope this is true. Let's try running it. Yes, that does pass. So I think this is the very first thing I can do, which is just correct that oversight and add ref_null to these tests. Yeah. In fact, let me just run the whole thing to make sure that everything's fine. But I would just say, how did I always phrase this before? Add ref null.wast passing tests. And then I can say, I didn't mean to omit this before. It was a mistake, which probably happened because ref null and ref is null are so have such similar names. This now means that test.sh is running all 90 of the test scripts in spec test core. Can I do one of those? Is that allowed? Great. Okay, so that is actually the point at which we're running all of them. It's a bit silly that ref null is on the end like that, but such is life. So, yeah, you see there are a few bits and pieces here. Oh, I forgot to do the thing that I have been doing, which is just pulling the latest version of the spec. let's just see what has happened. So yeah, this was my fix to the documentation. Some other fixes to the, it looks like the operational semantics there. This was this change to that linking.wast, moving it out into the SIMD tests. These look like changes to the JavaScript API tests, I think. Yeah. So, okay. So nothing too serious there. I think maybe I will. I think I do actually want to undo these. So can I, does this work? Can you do this? I'm not sure that that does work, does it? What happens if you give it multiple commits? Oh, given one or more existing commits, revert the changes that related patches introduce. Oh, it just does multiple commits. Okay. I don't really want to do that. I think I will just do it by hand. In fact, why don't we just, if I just restore this and then, oh, there's actually rather a lot of changes. I was going to say like, oh, I can just, okay, no, that's not helpful. I thought there'd be, I thought there'd be fewer changes than that. Okay, let's just do it by hand. There's probably a better way of doing this, but I don't know what it is. If anyone knows, then please do tell me. But basically it was just this bit. And this bit. So I think that's that change. Just removing the vector thing there, and then the vector case, and then the parse vector. And then there was also this commit. Right, which kind of sends execution down that path. So this is numeric opcode regexp. So previously it was just, right, yeah, like it was this stuff that I added. Previously it was just this, I think. Yeah, that's right. So now we should see the, if I save it. Yes, we should get that changed to numeric opcode regexp. I just want to eyeball that and check that I haven't done anything silly. FI bits 3264. Okay, all right. Well, there was probably a cleverer way that I could have done that, but I don't know what it is. So what order were those in? A37 was first. Okay. So let me just run the tests again. But I think, yeah, given that those tests have been moved out into the SIMD directory, I think I can safely remove all this. Let's say temporarily remove half-baked SIMD instruction support. Well, I mean, it's really it was really v128.const parsing support, I think. That's more specifically what I was doing here. Is it wasn't implemented in the interpreter, but just here when we were inside the const branch. So yeah, it was just the ability to parse it. Okay, that looks all good. Oh dear, I'm still in. Okay, well that was silly, wasn't it? Okay, all right. So I'll say I added this in blah and blah. I think these are actually the other way around. Because a recent change in the WebAssembly in the official WebAssembly tests. So maybe I can just pull that up. So it was this one. Added some uses of v128.const outside of the test core SIMD. Yeah. This was even more recently fixed by moving those uses into test core SIMD. So we don't need this dummy parsing code anymore. I'll bring it back whenever, when we get around to properly implementing SIMD instructions. Okay, cool. I'm just going to run the tests one final time because I feel nervous about how I bodged that just then. Okay, so that's, I think, an okay bit of cleanup from last time. I do think perhaps this is worth doing. So this was something that... I was thinking about the fact that... Well, really, I started thinking about, is it worth trying to use YJIT? And I've got that as a stretch goal down here, try YJIT. In fact, why don't I just try YJIT instead of continuously talking about it? Let's try YJIT, see if that makes the test any faster. So actually what I'm going to do is time running the tests. And let's just, I'm piping out to dev null so that we don't see the output. We're just going to see the result of time. There's a temptation to let this run in the foreground, but I think that's just superstition. That's the it doesn't care. The operating system doesn't care whether that terminal's in the foreground. GitHub, Ruby. I'm just trying to remember how to turn YJIT on. YJIT MD. Ruby enable. There we go. Yes. So you can do ---- YJIT, but I think maybe that's fine. I'm not sure how this behaves when you don't have YJIT support. I think it probably just emits a warning, but I think probably the safest thing to do is just to set this environment variable Ruby YJIT enable. So there we go, 42.64 seconds. Let's try enabling YJIT and see if that makes any difference. And the reason why I like that is that it's obviously easy for any version of Ruby to just completely ignore this environment variable if it doesn't care about it. Whereas if we pass ---- YJIT, I don't know why, I'm just slightly nervous about passing a new command line option. Is there stuff? I'm just trying to remember how old a Ruby version I currently support with, the Ruby features that I've used so far. I can't remember. Maybe it has to be Ruby 3.2. I guess I'm using data.define. So I suppose we probably are sort of stuck on YJIT, stuck on Ruby 3.2 anyway, so this doesn't matter. But given that there is an option that lets you just set an environment variable, then I think that's fine. It's not very much faster. Let me just check. What is it? Run WAST. Let's just check here. Standard error dot puts. I think it's Ruby VM YJIT enabled. So if I take this out, false, 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 false. Okay, that's what I expected to see. And then if I put this in, is this picking up the environment variable? True, 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 true. Okay, yes. So, so it does make it go slightly faster. It was like 2 seconds faster, 40 seconds rather than 42, which is not great, but I'll take it. So I will commit this I'll commit it now. Enable YJIT. Actually, I can link to this documentation. What tag shall I use for this? 3.2, I suppose. Go with 321 because that is the most recent. Oh, but now fragment identifiers aren't as well supported in the world as they perhaps should be. There we go. Okay, enable YJIT in test.sh. Well, let's say when running WebAssembly test scripts. Edit. I've chosen to set Ruby YJIT enable rather than pass YJIT command line option because the former is easier for old Ruby versions to ignore without complaining. this isn't particularly helpful since we're already using Ruby 3.2 specific features elsewhere, but I don't want to make the situation worse for no reason. On my machine, I'm just going to look at the timings again. Yeah, 42 to 40. Oh, I suppose total is what we really care about here. No, let's go for user. This makes the test take 40 seconds instead of 42 seconds, which isn't amazing, but I'll take it. Now, the thing I was going to say was, I don't think this is being particularly fair on YJIT, because the test script just invokes the Ruby interpreter over and over. So, you know, all of the work that YJIT is doing to find, like, patiently waiting to identify hot methods in the WebAssembly interpreter and then JITting them so that they've been turned into machine code that's stored in RAM, so that they can use the machine code rather than interpreting the Ruby, is then immediately thrown away when each test finishes, and then the whole thing has to warm up from cold again. So I think it would perhaps be fairer if we were able to just pass in a big list of the files to run. So I'm just thinking, what's the... Well, actually, perhaps I could kill two birds with one stone here. Like, I was saying use a glob to run all the test scripts, and here I was saying YJIT plus single process equals faster tests. The reason I'm hesitating is that if I wanted to pass all of these as command line arguments, none of them have got .wast on the end is the point. I'm just trying to think what's the tidiest way to do this. I realize I haven't even thought about Zeta's suggestion yet. I just wanted to get this out of the way. Maybe I can just kill two birds with one stone here. Maybe I can just say this just becomes star.wast. Oh, okay. So at the moment, well, at the moment, I think what this is going to do is, well, that won't do anything because this dollar file isn't defined anymore. But this is just going to, at the moment in run wast, this uses argf here, which is just going to be the concatenation of all of those input files. So if I run it in this state, then what's going to happen is that it's going to concatenate all of the tests and parse them as one massive test script, and then it's going to evaluate them. And I don't think that's what we want. I mean, I'll run it just for fun, but... Oh, hold on. Did I not save it? Oh, no, hold on. Those are the unit tests. Okay, yeah. So I'm now expecting we're going to be waiting 40 seconds or whatever. Well, maybe a bit less if YJIT gets an advantage, but maybe more because this is going to stress the parser a lot. Like, the parser is going to have to build an absolutely massive abstract syntax tree here. And so anything badly behaved in the S-expression parser or the preprocessor or the AST parser that is not linear in the size of the input could potentially get even slower. So I don't quite know who's going to win this game, but the longer I talk in this long sentence, hoping that the tests are going to complete. I mean, it's still parsing, and we should start seeing green dots as soon as it starts actually executing it. So this doesn't bode particularly well. So yes, maybe this was a silly idea. Oh, no, okay, there we go. So it is doing something, but I think we've already blown the 40-second budget. It feels like... Yeah, okay. So it was 79 seconds. So it was like twice as slow. Oh, and also it failed. Oh, dear. Well, that's interesting. It shouldn't have failed. So there's probably a bug somewhere. Okay. Why does assert return invoke load i32.const 0 fail? So it's something like this: assert return invoke something like that. When all the test scripts are run concatenated together. Like, I don't actually want to investigate that right now, but that there is... This should have executed successfully, but it clearly didn't. I mean, actually, we didn't see it run successfully in YJIT before because I was piping it to dev null, but because the runtime was comparable, I sort of believe that it was running all of the tests successfully. But that's worth double checking. But anyway, I think this is probably not right. I think what I should be doing is this should be something like argv.each do file name or something, and then we should be doing this in a loop. And this should just be puts. This can just be interpolation. Oh, in fact, this should be print, because the whole point of this is that it prints the file name, and then without new line, we get the dots after it. So hopefully I sort of implied this or kind of explained it, but just to be really explicit, what I'm trying to do here is make it so that we, for all of these test scripts, we start the Ruby interpreter once. All the rest of this can still be... We can still basically start again from scratch. So this is making a new interpreter object, a new parser, a new preprocessor. So it's not like I am intentionally reusing any of the same objects, but it's all happening inside the same process. So any work that YJIT is doing to, like I said, sort of JIT compile any of the Ruby code is at least we're gonna get more of a return on that investment. You know, just-in-time compilers are all about investing some work up front in the hope that it will pay off later on in execution. And so by making there be more later on, that makes it more likely that that work is going to be sort of amortized rather than just being a pure cost. So yes, so this, what do I want to do here? File.read. I think that's probably what I want to do. Yeah, I mean, at some point it'd be nice if this could take an IO object and It would be nice if all of this was incremental, but it isn't at the moment. So I think this is the kind of thing I was hoping for. Let's run it now. Oh yeah, the file name's a bit uglier here. I mean, I guess that's fine. But I could just print out the last part of the path name, so I'll probably do that. Okay, the question is this going to be any faster? I mean, it's not massively faster, is it? Feels like time is still passing. It's not executing in 3 seconds is what I'm saying, which is obviously what I was hoping for. Oh. Well, let me pipe it to dev null and see if, because, you know, some of that time is spent doing I/O to print out all those dots and stuff. That's a bit disappointing though, isn't it? I thought that reusing the Ruby process, or, you know, keeping the same Ruby process would make stuff go faster. So yeah, that's not the result I expected. So it was a bit of a waste of time, wasn't it? I'm not sure I have a convincing explanation for why that's happened. I mean, obviously I could investigate, but it's just not. I mean, I'm extremely naive. I don't really understand anything that's going on here, but I just would have thought that that would have given YJIT more of a foothold. I assume if this is legitimately slower. Why is it so slow? If this is legitimately slower, which it does seem to be, then I can only assume it's nothing to do with YJIT. But I'm just confused about... I'm confused about that. Well, that was a dead end, wasn't it? I mean, I suppose the 3 question marks here were justified. But yeah, I was just hoping that would be faster. Well, maybe I won't do the single process thing then. I mean, if it's just going to make the test slower, then there doesn't seem any point in doing that. Although I've got no idea how much to trust this. Like, is this going to take 40 seconds again, or is it now going to take a minute? Like, is it just, you know, something else that's going on my machine that's making this go slower? Like, this doesn't feel very scientific at all, does it? So perhaps I can't even make any sensible decisions relating to test performance here. Maybe I can do the GNU parallel thing, is what Chris is thinking. And I'm thinking, maybe you're right, Chris. So yeah, like that's, the whole thing is much slower now. I don't know why the first time I run the tests, they're nice and fast, and then they get slower every time I run them. Like, I don't understand what aspect of the state of my computer is changing that makes that so. And I'm just looking at OBS slightly suspiciously, but it's OBS is only using 10% of my CPU. So it doesn't seem likely that that's the culprit. So how can I... well, firstly, I obviously can't make any sensible decisions here. So maybe I'll leave this as it is, but can I just do some globbing here? Can this just be I fear I'm a long way out of my comfort zone here. Like, am I allowed to do that? Like, if this was instead of script, if this was file. And then this is just file. Like, is that a thing? Yeah, I really have no idea what I'm doing. So this, like, shell scripting is a long way out of my comfort zone. So, oh, I mean, I guess that does work. I mean, I think that's an improvement. Like, now that they are all passing, I think maybe just sticking that there and allowing it to run all of them in lexicographic order. Oh, I suppose that's the main difference, isn't it? Is that now they're being run in a different order. Yeah, it'll be interesting to see whether... Yeah, maybe it is the order that the tests are being run in. That's I hadn't occurred to me that is a significant change. Well, I certainly don't want to make a change that just makes the tests take 20% longer. Oh, I didn't time that one. God damn it. Okay, so what have I changed here? Right. Well, but surely that doesn't... Surely that doesn't make an important difference. I'm going to stop messing about with this in a second. I thought this was going to be like an easy and fun, oh, let's make it clear that I'm running all of the tests type thing. But it's very quickly turned into yet another distraction. So maybe I'll park this. I think this is probably fine though, especially like if I'm not trying to run them all in the same process. And particularly if I want to do the GNU parallel thing that Chris is suggesting, then this is probably fine. I assume... How does GNU parallel work? I assume I'd have to install this. I have used this before, but it was a long time ago. So, I mean, essentially you just give it a command and you give it some inputs and then it slices them up and runs them on multiple cores, right? Or in multiple processes. And then hopefully your operating system will do something useful with that. If you prefer reading a book, no. Otherwise start by watching the intro videos, no. If you want to dive deeper, spend a couple of hours walking through the tutorial. No. Let's look at the examples. Okay, look. Still not. These aren't examples. This is just a man page. Okay. I just hate all these tools. Okay, so it does work a bit like Xargs in that you have to put some kind of magical nonsense. Like, just to explain what I dislike so much about this, it's like, what's minus minus best doing here? Is that an argument to gzip? If so, why has that been made part of this example? Is completely irrelevant. So does parallel just decide how to do that in parallel? Okay, right. I mean, this seems to be every time I run, this is what I've been saying anecdotally, but now I suppose it is being borne out in reality that like now it seems to be half the speed of what it was when I started doing this. So maybe I should stop running the tests because every time I do it makes them slower. But this would suggest that I can... GNU Parallel can take the arguments from the command line instead of standard input. To compress all HTML files in the current directory using gzip run. Like, is this triple colon some kind of separator then? Like, why doesn't it say that? Oh, the ergonomics of these programs is just so awful. Let's just see what happens if I brew install parallel. Oh, okay, of course. Okay. All right. Maybe you forgot triple colon. All right. Okay. So let's just see what happens if I say it's like Ruby minus I lib run was.rb spec test core star.wast. No such file or directory, triple colon. Well, that's because I forgot the parallel, didn't I? Oh. Thanks, Paul. You are right. I didn't put parallel. I mean, it should have just magically known that I meant parallel, but it didn't. Oh, what's it doing? Okay, well, I mean, that seemed quite a lot faster, didn't it? I think, yeah, well, I think OBS is dropping frames is what I'm trying to say. I don't understand why. Maybe it's just the GUI that's dropping frames. Okay, let's see how this looks. What's it doing? Oh, it's just running some. Yeah, okay. So that was a bit faster, wasn't it? I mean, I think this is saying that it used 115 seconds of user time because it was across multiple processes. Yeah, Paul, you think it's I think Richard Stallman's getting his revenge through through the medium of GNU Parallel because I wasn't sufficiently deferential. I don't know what to think about this. I'm a little bit worried that I'm getting distracted by something unimportant here. What do I want to do? I think what I'm going to do for now is just this. I'm just going to make this change. So I'm essentially not changing anything about how it executes. one of the reasons I'm resisting GNU Parallel, Chris, is not just because of the unpleasant documentation, but also I want this to work on GitHub Actions as well, and I think I'd have to faff about with making Parallel available on GitHub Actions. And also, that wasn't... I mean, it was definitely faster, but it wasn't like loads faster. It was like a bit faster. Well, I mean, arguably, depending on how long these tests are arbitrarily taking, it could have doubled the speed. Maybe I need to understand how GNU Parallel works. Like, how does it decide how many copies to run in parallel? Number of jobs. No, number of jobs. Well, what's the default? Default is 100%, which will run one job per CPU thread on each machine. So you also use cores instead of threads. Determine how GNU Parallel counts the number of CPUs. Sockets, cores, threads. Normally the number of CPUs is computed as the number of CPU threads. Most users will not need these options. Use CPUs instead of cores is a misleading alias for use sockets instead of threads. Oh, and use CPUs instead of cores is obsolete. But I want to use cores instead of threads. Let's just see what this does. I mean, this is becoming a bit silly now, but let's just see what this does. Okay, well, I didn't see what that notice at the beginning said. Yeah, the OBS UI is super choppy. I don't know what effect that's having on the stream. I mean, of course, I don't know whether that even improved anything. It was a little bit faster. Oh my god. Look at this. And it won't cost you a cent. If you pay 10,000 euros, you should feel free to use GNU Parallel without citing. Oh my goodness. What an amazing piece of software. Okay, sorry, I don't mean to be... I'm not trying to be snarky. I mean, that's great. That is faster. I'm going to write this down and think about it. Because I think that is actually a significant improvement. But like I say, I think I'm just gonna, rather than get sucked into playing with this anymore, I think I'm just gonna stop at this point. Just so I can get rid of this exhaustive list of all of the test scripts. So I'll say use a glob to run all the test scripts instead of listing them explicitly. we are now running all of them, so we needn't name them individually. This has the advantage of telling us, well, of failing fast if a new test script somehow gets added. And we haven't, and we don't yet support whatever it's testing. Okay. Okay, that's fine. I mean, this pending section isn't doing anything anymore, but I'll just leave it there for now in case we decide to use that next. Oh, I've just realized that I forgot to add the preprocessor test to this. That's a bit of an oversight, isn't it? Why was there no new line there? What's going on? What's going on? Why has that happened? What? I don't understand how that can happen. Hold on. So look, without that, that's fine. What the? How can that? Oh, is that just a property of preprocessor test? Yeah, okay, I didn't put a puts at the end of it. That's real professional, isn't it? Yeah, very important to put a puts at the end of your unit tests. It's a little tip for any programmers out there. Oh dear. What this is amateur hour. Okay, run preprocessor unit test from test.sh. And this is print a new line at the end of the preprocessor unit test. Okay. All right, well, no performance gains made, sorry. Let's say, so I'll just put mystery here. I have tried YJIT. It is helping a little bit, but not much. So that's okay, I suppose. Okay, so now I actually have to do some work, don't I? Because I've just spent an hour mucking about and not really doing anything important. Oh, I guess I'm doing this now, yeah. User glob. So these two kind of, I think these belong together as like, well, I'll stick them here because they're sort of related mysteries. Okay, so some refactoring stuff up here, right? Move logic out of initialized memory into, oh, this was the thing that Zeta said last time. that stuff should be moved out of the initialize memory method. This is me remembering that there's still code that sort of ad hoc sets the current module inside the interpreter, and it doesn't need to do that anymore because we manage the current module, because each function knows what module is its parent, and we just set that as part of evaluating the function body. Build exports just had some repetitive code in it. All kinds of changes here. I mean, this is just a long... Oh, look, flesh out dummy table.init. I think I did do that last time, in fact. Did I do this? Extract instantiate. Yes. So actually, I've already done some of this. Think about what running an example program might look like. I mean, that's sort of related to what I'm saying up the top. This is all just refactoring, cleanup stuff. I mean, I could easily spend hours just working through this laundry list and checking stuff off. Most of these are small things, but I would really like to make progress on the bigger things. Break ground on a public API for loading and using a WASM module. Yeah, so I mean, what I'm thinking here, I don't know if I'm going to do this yet, but what I'm talking about is being able to say, like, require wasminner, and then do something like, you know, foo equals wasminner.load file.read foo or whatever, and then be able to like call foo.bar, you know, like something like that. Or I mean, maybe it would be more like puts foo.invoke function bar 1 2 or something like that. But also, I don't see why it can't be like this. I mean, let's just briefly have a look at oh wow. So this is the kind of thing I'm talking about, right? So this is WebAssembly.instantiate streaming, and then you get a promise, obj instance exports exported func. Okay, so there's something not entirely dissimilar going on here, where it's like this exported function here that calls an imported function with 42, it looks like, actually does get exposed as a JavaScript function. And yeah, it sort of provides this idea of like, here's an import, you know, here are the imports. So yeah, something like this. I mean, instantiate streaming is a bit of a mouthful. I guess that's my non-streaming equivalent to what I've written there. So I mean, maybe this would be instantiate. Maybe. Like, I guess this returns a promise. And yeah, you can sort of have an optional. So I mean, maybe this API is sort of the broadly what I can be trying to model here. But I think if anything, this, yeah, I mean, this is a little bit object.instance.exports. So this is a similar thing. The WebAssembly.instantiate, you give it a bunch of bytes, which is sort of what I would be doing here. You give it an object that's got all the imports in it, and then yeah, you get an object back, and that's got an instance property, and that's got an exports property, and then that's got the exported function. I mean, I don't know enough to understand why you need to drill down. Like, what is this object that comes back? Well, maybe I can look at WebAssembly.instantiate and that will tell me, but why do you have to get its instance, and then why do you have to get its exports? Like, why is this object not just got a exported func property on it directly, you know? But I'm sure there's a good reason for it. The return promise resolves to both a compiled WebAssembly module and its first WebAssembly instance. Resolves to a result object that contains a module and an instance. Okay. I'm not sure what a WebAssembly. I mean, I'm going down a rabbit hole here. I'm not sure what this stuff means. I mean, I know what a WebAssembly module is, but I don't really know how this API works. Clearly, this instance is like an instantiated module. But it's just got an exports property. I'm not sure what the point of that is. I mean, I see no reason up front to care about the way this API works. Like, you know, if there was anything really obvious here, I think I would pay attention to it. But maybe this, you know, maybe what I had to begin with was totally fine. But for this to work, it would have to do some... It would have to do some type conversion. Or, I mean, I guess, depending on what this thing does, maybe not. Yeah, I mean, maybe... You think about this. I'm just thinking about what I want to put here. Maybe it's okay to just put a string literal here. I'm just thinking what I want here is like a module. Well, some inline module. You know, this should be like example.add 1 and 2. Well, let's say assert, raise unless example.add 1, 2 is equal to 3. This would be source. So this would be something like, I can't remember the syntax, but it's something like func export add. God, how does this work? Is it like param i32? Is that a thing you can do? And then just say like i32.add. Is that WebAssembly? Let's see. I know I should know this by now, but I can't really remember. So if I require wasmina s expression parser, new parse. Oh, except no, this is going to work, but it's going to give me an array of. Okay, so I've got my module, A preprocessor. So can I do new process? See, I think I want process module, but that's a private method. Don't tell anyone. Okay, so that's interpreted the export correctly. Okay, so it's possible that that's right. So I'm not really in a position to be able to execute this, am I? Let's just see. How far away from being able to do this am I? Because if I could hook up something like this, then this is much more convincingly a WebAssembly interpreter, right? Like, and I've got all of the difficult bits. I just haven't got the easy bits that make it possible. So really, I have to call evaluate script is what it comes down to. And that will, although there are no assertions, that will populate the modules. So I think I can do interpreter is a new one of these. And then if I say process script and then I give it a fake script that just contains that is it evaluate script? No matching pattern error. Well, I mean, I've probably got some of the syntax wrong, haven't I? Okay. Oh, I've forgotten something important, which is the AST parser. Because, of course, you can't just wang an S expression directly into the interpreter. That is not how it works anymore. So AST is wasminer AST parser .new .parse script that right. And now I think maybe I can do this. Oh, well, that didn't work. Oh, for goodness sake. AST is what to evaluate. Right. Right. But there's no way to invoke a function. Oh God. Like interpreter stack. So if I wanted to evaluate this function with like, I'd have to do like interpreter dot stack dot push. Let's add 2 and 3 together. Push 2, push 3, interpreter invoke function interpreter. Well, let's see if I can get the function. Interpreter dot modules dot first functions. Okay, so there's my function. So I'd have to do interpreter oh, is it private? Invoke function, and then it would be interpreter.modules.first.function 0. Length mismatch. Evaluate integer instruction, expected 0, given 0, expected 2. Oh, right. That's because my original... Okay, look, we are getting somewhere. We are getting somewhere. I just wasn't thinking straight when I wrote this code. So for this to work, I'll make a folded instruction here, because it's like local.get 0, local.get 1. Is that right? Something like that. Because, yeah, I just forgot that I need to... These two things... For some reason in my head, I thought these two things are already on the stack, but they're not. They get... As far as the function body is concerned, the stack is empty at this point. And in fact, the stack is actually empty at this point. So it needs to get these two locals, and then it can add them together, and then this will get... The preprocessor doesn't do this yet, but this will get unfolded into the correct sequence of first local.get0, then local.get1, and then i32.add. So Wasmina preprocessor.new.process. Oh yeah. Well, actually, why don't I just do what it wants, which is have this inside a... Oh no, I don't need to put it in brackets. This is already going to be... Right, okay. Yeah, I'll just stick with this. Desugared S expression equals Wasmina preprocessor dot new dot process S expression. Process script. Right. Okay, and then AST is Wasmina AST parser dot new dot parse script desugared S expression. Okay, so there's my AST. And then let's make a new interpreter. And then interpreter dot evaluate script AST. Then let's push 2 and 3 onto the stack. And then let's run this private method to invoke that function. And then interpreter.stack.pop1. Hey. Okay, so that's real. That's real. So maybe I should just write that down in an acceptance test. Obviously, the API leaves a lot to be desired here because it's horrendous. But this does at least mean that it's possible. It is possible to actually run a WebAssembly function, like a function in a WebAssembly module. And then if I write it down and make it part of the test suite, then I can iterate on it and actually kind of polish it up a bit. Which is clearly going to require some refactoring, because at the moment none of this stuff is designed to be used in this way. I mean, even designed is too strong a term for what it's been. None of it has organically grown to accommodate this kind of usage. So let's just, I'm in this, what was that file? Oh, foo.rb, that's not really what I want it to be called, is it? So let's call this source. Do I have anything nicer in these? Like, do I have any complicated string constants? Did I make any decisions about? No, not really. Okay. Maybe I can just do end of source. And then at least I can sort of slightly present this. Something like that. Oh, and it this needs to have a result type as well, doesn't it? How does that? I've forgotten how that looks. Okay, param result. So you can say param result. Okay, so I'll just say result I32 here. I mean, I think this doesn't make any difference, given that I don't have a validation phase. You know, here there's supposed to be this whole, this is basically the type checker, but also I think it checks other stuff, and I'm not doing any of that. And I think that's mainly what this gets used for. Although I guess it also, I think maybe I refer to this when we do the stack unwinding, when there's a return in the function body. I think the result type is used. But anyway. Okay, so that's the source. The S expression. Yeah, I mean, I guess what I'm doing is, instead of writing, you know, fantasy code here, I've actually now got into writing the actual code that will currently work, which I think maybe is more useful than the sort of fantasy land stuff. So it's like, it's very similar to all of this, isn't it? Like, so parser, interpreter, preprocessor, S expression parser, parse it, desugar it, parse it again. So yeah, I want to do interpreter equals interpreter new, and then evaluate the script, stack, push. You can give this multiple. Yeah, okay. So I can push 2 and 3, and then I can say, well, let's say arguments is equal to 2, 3. We push the arguments, results equals interpreter.stack.pop 1, and then raise unless results equals 3. Of course, in the middle, I need to interpreter send invoke function. Well, let's say function equals interpreter dot modules dot first or last. Doesn't really matter. It's the only one. Let's say first. Functions dot first, I suppose. Okay. Oh. Oh. Right. Yes. Of course. Addition. I just was distracted by this one down here. But yes, I changed the inputs. Okay. So I'm just wondering whether I can package this up. How does... Just trying to remember how begin blocks work. I can never find what I want here. Yeah, there we go. Miscellaneous, begin and end. Oh, yeah, right. I'm always confused about this curly braces situation with begin, but yeah, what I was hoping I could do is have a sort of a begin block down here that does all of the setup. And I guess that would be... I literally don't know what I pressed there. So that would be doing all the requires, and sort of wrapping up the important bit of this. Oh, actually, hold on. Before I do this, what I should be doing is pulling out the appropriate export, right? Like at the moment, I'm just doing functions.first. Does the module name actually do anything? No, we don't really do anything with it. We just keep it. It just gets stored on the module, right? But it doesn't actually go anywhere. It's not like we keep a map of modules by name or anything. I'm just trying to make this a little bit more explicit, I suppose. But I should here be able to do like exports. Hold on, is it just, can I just do this? Or is that not how it works? Oh, okay. Sorry, I'm making even more of a dog's dinner than usual of this. Okay, right. So I can use the exports, and that's what I wanted to, that's when I started doing this thing. I was thinking about like what I want basically I want to define some method here that takes some source and a function name and some arguments, and it returns the result. So just wrapping up all of this business. So I think this is it, isn't it? It would parse the source into an S expression, desugar it with the preprocessor, parse it with the AST parser, create an interpreter, evaluate that AST, in order to define the module. And then this would be function name. Arguments I've already got. Push the arguments onto the stack. Call invoke function with the function that I've just extracted from the interpreter. And then just return in fact, if you just do pop, presumably that's just going to return a single value, right? And so for now, I'll just assume that this is going to return a single value. So this would now become, well, let's just see, puts execute source add 2 3 5. Okay, great. So, I mean, I'm not really thinking about a public API yet, but this is just helping me to see like, well, I mean, I suppose this is the naffest imaginable public API, which is just you get this execute method. I suppose what this really should be returning an array. And actually, let me just think about what happens here. I'm just thinking about what happens to the type reference. Like this should get, a type def should be inserted. Oh, the type def gets inserted into the, sorry, I know I'm not being coherent here, but when we parse this, we have to generate type defs. But I think those only go into the, into the identifier context. I don't think they get inserted into the AST unless I'm confused about that. Okay, it's going to be all of this. Why am I so useless at computers? So I'm just thinking about... Oh, no, right. Okay. I'm sorry, I'm being very unarticulate, but what I was thinking about here is how do we know how many results the function has? And the answer is we look at the type index of the function, we use that as an index into the module's types array. So I think we probably want to get the module here. Interpreter.modules.first. And then we'll say type is mod.types slice function type index. And then this should be type results length. So that tells us the sort of resultarity of the function. Like by pulling out the 0th type from the module here, we can see that this is the type of the function, which doesn't live inline on the function definition anymore. It's sort of been synthesized as a type in the module, which is all work that I had to do at some point. It's just all sort of fallen out of my brain that I had to do all of this. But in any case, we can just look at the results to see, at the very least, how many results it has. Undefined method type index. Oh, it's not. Okay, yeah, it's not on the function, of course. What? Oh, it's on the definition? Hold on. Oh. Right. Okay, well, that's a different problem, which is that there's the runtime representation of the function. How do I get my source back? So S expression equals that. Desugared script. So the AST, oh yeah, okay, right. So I'm going to have to say interpreter modules first. Right, I haven't done that yet. It needs to come off the function definition, I think. I think that's right, because definition is the abstract syntax tree node. So we map over the functions from the AST, and then we cook up this new function object that holds on to the AST node. So here I was, in my head, this was the AST node, but it's not, because I've pulled this off of the exports from the runtime module. It's actually a sort of runtime function representation, and its definition, well, the two things that this function knows is what's its parent module and what's the AST of its definition. So I think I have to do this, and that's a lot of words for something I haven't actually tried yet. Okay. So I think this is the right thing to do because, because in general, WebAssembly functions can return more than one value. Although that does make me curious about the JavaScript API. Like, how does this cope with the fact that because in the end you just end up calling a JavaScript function here. You know, just calling exported func, but like this doesn't return anything. But like, how does this API cope with multiple return values from functions is what I'm trying to slowly work my way towards. We then call an exported WebAssembly function. Apparently there's a spec for this this JavaScript. Okay. You get the same kind of wrapper for the underlying function. It's as if every WASM function is a JavaScript function too, but they are encapsulated by the exported WASM function object instance, and there are only limited ways to access them. Okay. They are real functions. Okay. If you try to call an exported WASM function that takes or returns an i64 type value, it currently throws an error because JavaScript currently has no precise way to represent an i64. What about if it returns more than one? Surely that's more of a problem. Okay. Okay, how does this work? I've never looked at this before, so I'm already instantly on the back foot. Exported functions. Result types. Okay. This is not very explicable to me. This is something I was thinking about, is like, how do you typecast stuff? You know, we're going to have to convert. You know, I'm ignoring that for the moment because actually the underlying representation in the interpreter of 32-bit integers is actually just Ruby integers. But for floats, that's not true. Results size. Let result size be result size. So this is to run a host function. I don't know what that means. Oh, this is talking about lists. What the heck? Okay, well, I'm way out of my depth here. I don't even understand what I'm looking at. Like, I am not the intended audience of this specification. I just don't know. The WebAssembly sequence type is equivalent to the list type defined in the infra standard. Okay. So this is a demo. Okay, well, I mean, this is clearly not going to help me. The only reason I was looking at this is I was just curious about how, is there some kind of existing standard for how to deal with multiple results? Okay, that's unhelpful. Yeah, okay. Well, I appreciate it's not very gripping to watch me just scroll through a document, so maybe I'll stop this. I was hoping there might be something comprehensible here, but I fear that there isn't. Okay. Oh, look, I've accidentally found the answer. To call an exported function and a list of JavaScript arguments, perform the following steps, blah, blah, blah. If out arity is 0, well, let out arity be the size of ret, where ret is the result of func invoke. Not clear what it means by... Oh, I guess it's talking about result here. Let result be val star. Okay. So yeah, effectively, this is when we evaluate a function. It says, if out arity is 0, return undefined. Otherwise, if out arity is 1, return, like, effectively cast that to a JavaScript value. Otherwise, return an array of values. So maybe that's what I should be thinking about doing here is, if it's a function, let's say here, like case type results length, when 0, nil, when 1, interpreter stack pop, else so this seems to roughly correspond to what this spec is saying. Is like, I mean, and I've got no reason to conform to this. This is just something that, this is what happens when you call WebAssembly from JavaScript, I suppose. And so I'm just, rather than making completely arbitrary decisions, I'm trying to think about, I'm just trying to learn from what has been done elsewhere, I suppose. So does this still work? Yeah, I mean, foo.rb is not a very good name for this. What shall I do with this? Move foo.rb test, execute WASM. Um, let's call it execute function. Okay, so I think this is naff, but real way to actually run some WebAssembly code, right? Like this is the first time I've ever even tried to hook all of this stuff up, and obviously I don't even have public API for some of this stuff. Let's try. Well, firstly, I think I can probably take advantage of the inline function definition business because the preprocessor knows how to deal with this. Well, maybe it's less confusing to have the module around it explicitly. Actually, let me try another one. In fact, let's make this work like one of those other wonky unit tests. How do those other wonky unit tests work? Oh yeah, they've got these conditionals, haven't they? Oh, this is fine. I'll just leave it like this. Who cares? So what did I want to do? I think I wanted to try just having so how do you return multiple values in WebAssembly? Oh, I think you just have to leave them on the stack, don't you? Like, I think that's fine. In fact, there's really no need for them to be folded. So I think now if I give it 6 as an argument, I should expect to get 2 6s back. Great. Okay. I mean, what am I actually achieving here? I suppose what this is letting me do is sort of kick the tires of how should it work to interact with this from the outside. And I suppose at the very least it's allowed me to think about how do we deal with the sort of result arity of these functions. I think what I'm going to do is commit this much Um, so and I'll add this to test.sh while I'm in here. So this can be execute function test. Oh, mustn't forget to print out a new line at the end. So this will just be the, oh, we actually don't need the type here, just the function. And then I can write a separate commit message that talks about the result arity thing. So this is add initial rough test of calling a WebAssembly function from Ruby. And let's say this is a very long way from being a sensible public API, but it allows us to at least see what's involved in calling a function. We'll need to perhaps seriously refactor the guts of Wasmina interpreter to make this more sensible and add a new class and or wrapper object to provide a sensible API. Well, to provide a to provide the API. Okay, and now so that's all good, apart from I've lost the puts at the end. So this is going to say use the function type to decide how to package result values, and then here I can cite this. What can I link to here? I'm just hovering my mouse pointer around, hopefully. Maybe it's only this. Is there some kind of slidey thing? Pop out sidebar. That's not terribly helpful, is it? I guess it's this. What spec even is this? The WebAssembly JavaScript interface. As an illustrative example, the WebAssembly JavaScript interface specifies that. Does that not even work? Oh, it does. Okay. Well, says if out arity is 0, return undefined. Otherwise, if out arity is 1, return blah. Otherwise, make an array with the results. Well, maybe I can put that. Yeah, okay. There's no reason for us to necessarily match this API, but it seems like a reasonable compromise, well, a pragmatic compromise between what's convenient, i.e. most functions will either be void or return a single value, and what's usable in general, i.e. we need some way to support multiple return values. So we'll do the same thing for now. Okay. So clearly there are several bad things going on here. Also, just looking at this JavaScript API again. Yeah, so there's like methods that compile. Yeah, so this API makes a distinction between compiling and instantiating a module. Whereas I don't make that distinction at the moment. This evaluate script will just read all of the modules in a script, and I mean, I don't know what compiling them would entail, but it certainly instantiates them. I don't know to what extent this is going to explain. Compiles a WebAssembly. I mean, I guess this is mainly about parsing and assembling the WebAssembly module. Effectively, this is a thing that turns the source into this WebAssembly module object. Oh, right, but these are all just descriptions. So this allows you to sort of look at the metadata, I suppose, of what's exported. Oh, it doesn't say. Okay, well, I don't want to get too hung up on what JavaScript does, because this is not JavaScript. But I do just want to think a little bit about how I would like this to work. You know, what I started writing earlier was this kind of wasminer load source. So I mean, what would this, if I wanted to do this, what would that look like? If I wanted one of the, instead of this execute source add business, if I said mod equals wasminer load, what am I doing? Source, raise unless mod add 2,3 equals 5. Like, what would that look like? Well, based on what I currently have here, I mean, this is a little like well, look, here's a silly way of doing this. I was going to do this as just sort of a curried version of execute. But oh no, yeah, that's not going to work because we need to know the function name. So maybe I'll copy some of this. Sorry, so maybe I can do object.new tap do result. So this is going to be the loaded, I mean, let's call it instance, but that's not really what it is. A module instance, I mean. Obviously, it is an instance of a Ruby. It is a Ruby instance because everything is. So I've sort of done some of the work here to load this, to parse the source and to stick it into the interpreter. So I'm just thinking what we want to do is like, for all of the exported functions, define a method. But how do I get all the exported functions? I don't know if this information is available actually. I mean, this is what the exports hash looks like. Yeah, build exports. Yeah, they all just get smushed together into a single namespace. I'm not even sure that that's necessarily right, but I think it probably is. I think the names probably have to be unique. But there's no straightforward way to just look at this and, well, what I'm going to have to do is say mod exports each do, you know, wow. Well, for now, I'm going to just do this. Because actually, let's just say if value is a function. That's a wasmina interpreter function, I think. I don't need to specify. In fact, all of these, I can get rid of this prefix because that is the namespace that I'm in. So if the value is an interpreter function, then instance.define method key do args and then this is going to be the bridge, right? So here where we're calling the add method, this is where we're going to do that. And we do that by, I guess, raise unless arg's length is the same as function definition. Well, no, hold on, we need the type. So we'll get the type of this function. I can do that outside of here. Raise unless arg's length equals type is it params? Parameters. Let's call this arguments then. Let's not be, oops. Let's not be uncouth about it. So it's going to check that there are the right number of arguments at least. And then we just do the rest of this. So we push them onto the stack. So we sort of closed over the interpreter that we used again. So this is a bit of a mess. But at the moment, this is just how it's going to have to work. And then we just do this. Function here. Well, maybe instead of key and value here, we can do like name. Well, that's fine. Just call this value. I think that's the thing. So we make an empty object here, and then for each of the exported functions, we define a method with the right name that essentially calls that function. Does that work? No, because it's not called function. Let's just say function equals value here. So that this can be called function. Actually, let's just go for it. Let's call this name, and let's call this function, and let's just call this function. Because at the moment, well, I'm changing my mind about this. It doesn't matter. It's not important. I think this will be fine. That's fine. Ah, yes, you're right. I did mean define singleton method. or I could have used the meta class there. Okay, right. So that works. So now I can rewrite this one. Excellent. All right, so this is, again, still, this has got pretty hacky now. But this is getting closer to what I was thinking. Can I just, how about, how does this work? Select. Yeah, that's fine, isn't it? Because the hash is just enumerable. So if I just select sorry, that's just making a huge mess. Okay, I'll leave it like this and say set up a wasminer load method in the test to create proxy objects. Yeah. Let's say this is closer to a nice ergonomic API for making WebAssembly modules available in a Ruby program, named methods that you can call. I mean, all of this just makes me realize that what we've got in the interpreter at the moment isn't really fit for purpose. Firstly, it's all designed around evaluating a script. So there are many, let's make a list of many problems with the interpreter. Maybe I'll make a to-do list out of this. You can only evaluate or parse or pre-process a script, not a module. Perhaps it's a problem that there's no distinction between compiling and instantiating a module. I don't know if that's But I don't know if that's a real problem yet, since I don't even know what the important difference is, or why we'd want to compile but not instantiate a module. The module instances I'm not sure how to phrase this, but like the coupling between I was going to say the coupling between the module and the interpreter are perhaps somewhat coupled to the interpreter that produced them. Maybe we need to separate out thing that instantiates modules from thing that evaluates instructions, even though instantiating a module can involve evaluating instructions, e.g. the start function, initialization expressions, etc. For globals, etc. So instantiating a module isn't entirely a sort of an evaluation agnostic process, because you do need to do evaluation. But I don't know that it's necessary for the basically the name interpreter is wrong, and has been for ages. We should think about runtime or VM or something else that better captures the idea of I know how to execute instructions. I mean, the interpreter is the whole project. The whole thing is an interpreter, right? And at the moment, I've got this very poorly defined interpreter class that's actually got a load of different responsibilities, and that's sort of been fine up until now, because it's just been the sort of the junk drawer that I've thrown everything into. But now that I'm actually starting to pull on this thread and think about, like, well, how do if I actually want to have a client of this thing rather than have it just be something that, a test script runs a single method on and then a million things happen, like, what do I actually want the surface area and even the identity of this thing to be? Like, it's not actually that obvious. And I suppose this is the problem with having taken this sort of acceptance test driven shameless green approach to this project, is that I've just sort of barged through it without thinking about any of this stuff. And the upside of that is that it's given me a way in to getting 100% of those tests to pass. But the bad part is that I'm left with this gigantic mess. Yeah, I keep getting distracted by thinking about the different problems, but this is the reason to make the list. I'm actually quite sleepy. I didn't realize that. This might not be a long one, because last time last time was a bit of a special case, because I was trying to power through. The progress bar was at 99.9% and I was trying to power through to 100%, which I think was part of the reason why I kept going beyond my ability to think clearly. But I can tell that I'm actually already starting to get a bit tired, and there's no there is no such milestone that I'm about to hit here, so there's no real self-imposed pressure to keep going beyond the point where I feel like I'm being competent. So there's a big problem here with the visibility, with access to the stack contents. At the moment, we're literally pushing and popping stuff from outside of the interpreter, which feels really wrong. So I think this... It feels like there need to be separate notions of call this function with these arguments and get the results, i.e. Abstracting away the calling convention of the arguments and results living on the stack with reference to the function type, using the function type to decide how many of each there should be, and invoke the body of this function, because that's i.e. expecting expecting the arguments to already be on the stack and leaving the results on the stack afterwards, which is what invoke function currently does. I think that's right. Yeah, so this is the... yeah. So, I mean, we call invoke function in two sort of very different contexts. And one of them is sort of at this kind of top level, if you like. So this is, you know, I think this is analogous to us using the public API, because this is like the invoke command that can appear in a script. And, you know, the script is sort of just like a... well, it's like a script. It's sort of like functions that you... it's like commands that you perhaps would be able to type into a REPL if there was one, but they're just written down in a file. So this is kind of like using the public API. Yeah, this one's fiddly because the arguments to this are expressions. Well, maybe that's another thing. There's no good way to just evaluate a WebAssembly expression, e.g. for invoke. Because really, to evaluate a WebAssembly expression and retrieve the resulting value, how do we know if it has one? Could it just be everything remaining on the stack after evaluation? So yeah, there's a not very well defined notion here of like, if we're thinking about this invoke and assert return as being like almost, I don't see any reason why we can't think of them as like clients of the public API. Then it's not just function invocation that we need to deal with. It's also, yeah, this is a situation where it's like I've got the source of a module, but I've also got some expressions that I need to evaluate before I invoke the methods in that module. Yeah, this is starting to sort of pick away at my understanding of where's the boundary between the test scripts that the reference interpreter is able to interpret and the sort of underlying, the model of the world that WebAssembly as a language uses, which is things like modules with imports and exports, whereas the interpreter has things like register. It's sort of almost that REPL, that scripting environment has got this notion of like registering a module under a name. Which is what's used by invoke here. Find module. Right. Oh dear. So yeah, we want a cleaner API boundary for being able to, without access, I mean, ultimately the stack is an implementation detail, and given enough time and energy, clearly you can implement this interpreter. Well, I say clearly, but you can implement this interpreter without having an operand stack at all, right? Like, I mean, I think the simplest way for me to think about that is that you can just do a sort of register allocation exercise, or do like I'm not sure what the right way to describe this is, but you can do a sort of abstract interpretation where you go through and for every instruction, like figure out what the data flow is. Like, every instruction has got a known effect on the stack. Every instruction is either popping a certain number of values off the stack or pushing a certain number of values onto the stack, or both. So you can always go through and just say like, well, instead of using a stack, let's just invent enough local variables for all of the values that are going to go on and off the stack during the execution of this basic block, this chunk of code. And then you don't need a stack anymore. You've just replaced the stack with enough variables, but because you can track the identity of each value as it passes through the code, you don't actually need to push them onto a stack and pop them off again because of the validation constraints of WebAssembly, and because of the design of it. You never actually need a stack. You can always just statically understand what values go where, and the stack is just a sort of a convenient fiction that makes it easier to describe the semantics of the instructions. But like, it's not a fiction in my implementation at the moment. It's reified. There actually is a stack because that's the easiest way to implement it, but I don't want to expose that through this public API. Like, it really is an implementation detail, and I should reserve the right to make it go away in the future if I did want to do that sort of effectively a register allocation exercise. Clearly the user of this public API should not be directly interfering with the contents of the stack. Like, that is just wrong. So yeah, I need to think a little bit harder about, am I going to have, is it possible for me to extract some kind of VM that just has a public API that provides everything that the sort of script evaluator needs. Maybe that's a good name for that thing, like script executor or something. But also provides an API that can be consumed by whatever this is that I'm starting to build. The sort of the loader or the, this business, the WebAssembly Ruby API that bridges the gap between Ruby stuff and WebAssembly stuff. I wonder whether it's interesting at all to think about type conversions here. Because, well, I am a little bit interested in thinking about it, not least because it means I can slightly stall on having to deal with this right now, because it feels like a little bit intimidating. Oh yeah, I forgot I was doing that. Yeah, that's sorry, that's a distraction. So yeah, just what I was thinking about here was, what if these were 32-bit floating point numbers, and this was 32-bit floating point add, and this was a 2.0 and a 3.0, and we were expecting to get a 5.0, which, let's just double check that is actually what Ruby thinks happens. Yeah, always good to check with your floats. So I expect that this isn't going to work. Yeah, because f32.add is expecting that the values on the stack are integers representing, the bit pattern, the 32-bit pattern of, or it's like a bit field representing an IEEE 754 single precision floating point number, and it's going to try to decode that. It's actually going to sort of undo that transformation ultimately internally to turn it into a Ruby float to do the addition, and then it's going to convert it back again. So at no point are this 2.0 and 3.0 going to be useful. Well, they're not going to work, is what I mean. Right. Yeah, so it can't even start to think about that. Well, actually, let's think about something more fundamental. Because there's a more serious problem here. Crap, what do I expect to happen here? I'm thinking about signed numbers. I'm thinking about what happens if I want, well, yeah, what happens if I want this to happen? Because right now, that is not going to work. Oh, this is my least favorite Ruby syntax gotchas. Oh, it's a different problem. Okay. So yeah, so yeah, what's happened here is that I think we have actually ended up, sort of accidentally, we have ended up computing -1 here because this does just get added to the 2. But then it gets converted into an unsigned number because that's the sort of internal representation. I mean, maybe this is more complicated than the thing that I was trying to do before, actually. I thought that was going to be easier, but now that I think about it, I think it's easier to... Because this is a totally foreign world of floats, and I think just being able to deal with those is gonna fill out some of the infrastructure here. So I'm just thinking, well, so on the way in, these are going to have to be turned into the appropriate representations, right? I wish I could still remember when I was working on the float stuff. I feel like I was extremely good at printing out, like I knew what all of the format unpack. Oh. Okay, well I don't know how to get to that with RI. Okay, great. I want to prepare myself for what the right values are here. Packed data. Okay, so let's try and remember this. So if I've got an array 1.0 and I want to pack that as single precision floats, has this all changed? Like, is this new documentation? I think it might be. And I mean, it's sort of better, but, well, no, it is better. I like the look of that. And it might even be some people that I know who did that work. But I was just to orient myself, I'm going to look at the thing that I already, I was expecting to see this table, which is going to trigger a sense memory in me about exactly how all of this nonsense works. Yeah, I mean, I remember all of the integer nonsense with the little endian and big endian stuff. Do I still have anything in float? No. No, I think I got rid of all of that stuff. So I think we want little endian. So is that right? E? And if I unpack that as a 32-bit, I want it to be little endian specifically. L. Unsigned. Less than. Or I can use V. Ugh. Okay. Now if I pack that and unpack it as an E, I should get 1.0. Okay. Two 2.0, 3.0. Okay. I mean, I don't actually know whether any of those are right. Yeah, I mean, I really just can't. How did I... I really can't remember how all of this worked. Oh, yeah, we just ended up going through rationals in the end, and then... Yeah, okay. Right. Okay. This is not very interesting. I just wanted to confirm what the right values were here. So I think I can say Wasmina float from float 1.0. And then I think I can say encode Wasmina float format single. Oh. Is that the same number as I got up here? 10653532216. Yes. Okay. Right. So the gymnastics I was doing there were correct. It just gets there a different way. Well, it does it. I'm doing it myself rather than using pack. Okay. So that's all. Okay. Those are the values we're talking about, and that's also. That little bit of fiddling around has been a useful reminder of how the hell my float implementation works. because that's what I'm going to have to do here. In order to make this work, I need to convert these on the way in so that they are integers, which is because that's what F32 add is expecting to operate on, is unsigned integers that represent these numbers, that represent the encoding of these numbers. And then it's going to do its business, which incidentally involves decoding those into Ruby floats to add them together and then turning them back into an encoded integer. And then when the result comes out, we're going to have to do the opposite conversion. So I'm going to have to use from decode. Yeah, decode, and it needs to know the format. Okay, so this is all dependent upon having the type signature here to tell you what kind of arguments they are and what the result type is. So in here, there's going to have to be something that's like arguments equals arguments zip type parameters map can we do that? I'm a bit worried about shadowing type here. This should really be function type. Ugh, whatever. I'm wasting time. I mean, is that even a problem? I can never remember the rules for this kind of thing. No, it's fine. I don't know why I'm being such a baby about that. It's because I got burned by that, well, by having a local variable inside the block, and I had to make it a block local. But I guess for block parameters, it's always fine. Again, I think I'm getting better at recognizing that I'm getting sleepy and that I'm not really focusing properly, because that's the kind of thing that I just know, and I shouldn't be faffing around. I should just recall it. Okay, so the point of this was case type in, and I'm using a pattern match here because I actually do want this to be exhaustive. And actually, I could have done the same thing down there. Oh well. So if this is I32, because that's what we've done up there, then we just return the value. We don't do any encoding. If it's F32, then I think it's float from float, and then it needs to be encoded at the right precision. So let's make this. let's say format. Well, no, I know what the format is. Encode format, float format, single. So now when I run this, previously the exception we got was about trying to do sort of bitwise operations on floats, which isn't a thing that you can do. But now I'm expecting that the assertion is going to fail because I'm expecting the floating point operations to succeed, but then instead of getting whatever it is we're expecting to get 5.0 back, we're going to get this back, I think. Okay, not very helpful. This is why I put those things in local variables. Yeah, there we go. So that's exactly what we expected. And because we need to do the conversion on the other end. I think this is just going to need to be extracted out, isn't it? So what is this? What is this? Ruby to WebAssembly. Let's just call it to WebAssembly value. And then the reason I did that is because we're also going to need a from WebAssembly value that just does the opposite of this. So again, if it was a 32-bit int, that's fine. And this is like an uninterpreted int. This is why I hesitated before, is because I haven't really thought about what this should look like for if it's explicitly signed. But I'm going to think about that in a second. But for floats, so this needs to be float decode. So that takes the value. And I think just to F. So it makes me realize that I should probably be doing this. Because that seems to be what I've done. That's what I've done here. So I'll just be a little bit, consistent here. So this is just typecasting in both directions, basically. But sort of as the values cross the boundary between Ruby and WebAssembly, they need to be converted to and from whatever WebAssembly's representation of these values is. And again, this should probably be, well, no, I mean, there needs to be some layer like this. Like, it feels like this stuff does all belong in the same layer, that it's sort of like an FFI layer that is dealing with all of these details. So this is from WebAssembly value. Type is type results first. And I think, well, let's say, let's do this in pieces. So we pop the result off, and then we use the result type to convert from a WebAssembly value. Here we do results. We pop the right number of things off. And then we need to do results zip type results map do value type from WebAssembly value type. So that's gonna match up the values with the types of those values from the function signature, just like I did up here for the arguments, and then it's going to convert them in the opposite direction. Undefined method to WebAssembly value. Oh yeah, crap. Okay, well, let's just say wasmina dot. That'll have to do for now. That's not great. I mean, I think actually what I should do here, no, I'll do this first, and then I can see that I can clean up this code down here. Okay, great. So convert floats to from WebAssembly. 32-bit floats to from their WebAssembly representation. I think that's okay. What I was saying here is that I think really I can do this in one go. I can say results is interpreter stack pop type results length. And then, well, in fact, does zip? No. It's really unfortunate that zip, . if you give it a block, it just evaluates that block, right? It's like each. Yeah. Calls the block with each of the subarrays, forms above, returns nil. So I do need the map. Well, I'll do it in two pieces. Well, it's this. So we pop them off the stack. We pop the right number of them off the stack, and then we zip them up with the types, and then we convert them. And then this can just be when case results dot length. This can just be results dot first, and this can just be results. So that's slightly naff because we're sort of building an array, perhaps unnecessarily. But I think the need to do this type conversion on everything that we're popping off the stack, I think, means that it's easier to do it as part of retrieving that collection of values, even if it turns out that we only want the first one of them. Let's see if that still works. Yeah, it does. I think that's slightly better. So this will be like convert all results from WebAssembly, all function results from WebAssembly values before deciding how to return them, basically. This might mean that we're building an array of of 0 or 1 results unnecessarily, but I think doing the type conversion in one place, in a single place, is worth it. Okay, so we're sort of dealing with marshalling the values back and forth across that boundary. And at the moment, I mean, obviously there are all sorts of ways this could go wrong. If I said the arguments were both F32s, but the result was an I32, then this function is not going to work properly, but then this function definition would fail validation, and so far, because I haven't implemented validation, there's this sort of implicit constraint that the only code that we know how to execute is like valid code. So I don't need to do anything to account for the fact that that would not work properly. So like I said, I just wanted to think about, just briefly, about, see, number types are I32. It is only those four. So Uninterpreted integers can be written as either signed or unsigned and are normalized to unsigned in the abstract syntax. So I'm just thinking about, like, I didn't think about this very much before, but like, how should the type conversions work if I want a function to be able to return a negative number? Like, how does that look? I32 and I64 classify 32 and 64-bit integers respectively. Integers are not inherently signed or unsigned. Their interpretation is determined by individual operations. So it's not super meaningful. Well, let's just look at an operation. It's like numeric instructions. So it's something like subtraction that we know might return a negative number. I have to look at execution. Numeric instructions. So what's something that might have a signed result? Bin op C1, C2 is defined. Well, this isn't telling me what I need to know, is it? Which is how to interpret. So integer operators are defined on I(n) values. Operators that use a signed interpretation convert a value using the following definition. Right. Oh, okay, so here we go. Return the result of subtracting I2 from I1 modulo 2 to the n. So basically, I sub n yeah, I mean, essentially the equality comparison here like isn't particularly meaningful, because I suppose this is just what you have to, as the caller, this is what you have to deal with, is that the result value, well, let me just think about this. Getting a negative result value is actually maybe not meaningful, but I think providing a negative, I think being able to say add -2 and 3 and get 1 sort of is okay. Oh, and that just works. Right, but I think it might just work for the reason that I said. So if in the interpreter raise unless left raise if left negative or right negative. Yeah, this is integer addition. Unhandled exception. Yeah, so we're getting a -2. Which isn't really what we want. Like, that's what this is saying is integer operations are defined on these in values, and we need to take the 2's complement. So I think on the way in, we know if they're, well, I'm not 100% sure what to do about this. Maybe I am. So it's basically just this, isn't it? Like, we have to convert it to unsigned. And this already, I was just thinking, like, this already has the logic for, like, if it's negative, then we have to bump it up to be positive. And if it was already positive, which that's what I was confused about, is like, if it's positive, then what do we do? And the answer is we just leave it alone, regardless of its magnitude. It's only the signed one that cares about the magnitude. Excuse me. So I think it probably should run through this unsigned helper. So these values going in, this should be interpreter unsigned value bits 32, and I don't know whether that's a public method or not. Oh, it's an instance method of the interpreter, right? Of course, even though it actually doesn't, it's just a helper. But oh yeah, I don't have an instance of the interpreter at this point. Let's just cheat. You know, when you don't have an instance of something, you can just make one. All right. Hey. Okay, so okay, well, okay. So this is something like correctly convert inputs or integer arguments to unsigned integers. And I think I can link to this. Unless I feel like I read something more. Yeah, I think this is probably the right thing. Integers are represented as unsigned numbers. So we need to do the conversion before passing them to WebAssembly. There's currently no public API for doing this. So I'm having to call a private instance method on twice-minute interpreter, which is obviously not ideal. The purpose of all this test code is to help me to understand what public API is required, so it's okay to make a bit of a mess in the short term, as long as that mess gets refactored away as I create the API I need. Okay. So I'm going to say I have broken ground on this. I have started thinking about this, but not very much. It makes me realize that I haven't written down here under like things I could do next, maybe. I haven't written down implement, I think, assert malformed for parser errors, implement, what is it, assert invalid for type checking errors, and implement assert trap for runtime errors. So I've sort of been ignoring these. Yeah, it is in here. Assert malformed, assert invalid. Oh, assert exhaustion. Assert unlinkable. So maybe I need to talk about this next time. But this is another direction of implementing stuff, right? Is to be able to actually, instead of only running assert return, I could actually run some of these like detecting problem assertions. I don't know what made me think of this. It's not really relevant to what I've been doing here, but it's just, as I was looking at this list, it occurred to me that that was another thing that I could have done, but didn't get around to doing. Anyway, yeah, I was sort of focusing on problems here. I mean, I feel like all I've done here is create a problem to be solved, and the problem is all of this. You know, the design of this code isn't right to support any of this stuff. So I think maybe the next step is for me to I mean, you know, I do sort of have an API here. It's sort of inline in the test. But it does exist. It's just that the implementation of it is absolutely horrible. Because I don't have any of the stuff that I need to actually do it properly. I also do want to, thinking about it, I think I do want to look at using GNU Parallel here. I think this was a good idea from Chris. And I didn't want to get derailed by it, but I think once I get back into needing to run all of the tests, I think this is actually going to be pretty important. So I think I probably should, once I'm running the test, I think I probably should prioritize this a bit more. I kind of gave it a go and then just sort of gave up on it because I didn't want to go down the rabbit hole. But actually, I think this could potentially save me a bunch of time. So Chris, I'm sorry I didn't. Well, I did try it, but then I got frightened of it. I think it's probably the GitHub Actions part of it that I'm afraid of. But there's no need to be afraid of that, is there? I can just install it on GitHub Actions. So I think maybe next time I should, having checked that this works, I think maybe I should come back and make it work properly. I can feel myself, I can feel my brain slowly winding down, so I think I should stop in a minute. What would this look like? If I wanted to... If I wanted the output of this to look right... So annoying. If I wanted this to work right, I need to print the name of the test in the, because at the moment you can't see which test is running, right? But I realized the other reason I was resistant to this was, or is it a mistake to run one Ruby process per test script, which I think is what this is doing. How can I get GNU Parallel to batch up the test scripts and run several batches? Do I even need Parallel for that? I guess I maybe do. Oh, hi, Benjamin. Welcome. I'm glad you enjoyed the Elrog talk. Yeah, still no video of that, but I'm glad you were there and that you saw it. Thanks for I'm glad that has generated a viewer. So thank you for coming along. Unfortunately, I think I have just run out of brain juice for the night, so I think I'm going to wrap this up shortly. But anyway, yes, I think I need to think a bit more about GNU Parallel is my point. Is there anything else that I feel awake enough to do on this? I feel like I've sort of got what I wanted, which is to start, like, this is acting as like a bit of a forcing function on like what are my many problems with the interpreter. And I think if I could work on the design until all of these problems have gone away, I think that would really help. So it's unfortunate that it's taken me this evening's work to get to that point where I've got this sort of ugly code. But I think this does show me what I need to do next to get this actually usable. Like, I would really like to get this to the point where I can just maybe just write a README that's got something like this in it, you know, that just demonstrates that it's possible to do something. I mean, is there some function that actually does something? Is it like a Fibonacci function or something? Because those ones are a bit naff. Okay, well, call.wast looks like it's got okay. Well, these are these are interesting. I mean, they're not super interesting, but there's factorial. Let's try it. Maybe the excuse for this can be to have multiple functions. So there's factorial, there's Fibonacci, and there's mutually recursive, even and odd. So now if we load this, so factorial So how does Fibonacci work? Oh, if it's less than or equal to 1. Right. Okay, so this would... Well, let's do mod fac. What's some cool factorials? Well, that's too much. I think 120 is a factorial of 5. Yeah, let's do that. And I don't think that's going to work because it's a 64-bit integer. Oops. I64. And I'm going to need to go in the other direction. Okay, that works. And then I'm going to say let's say 5 times map mod fib equals, what is it, 1, 1, 2, 3, 5. I think we could probably go even further. 1, 1, 2, 3, 5, 8, 13, oh no, 21, 34, 55. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wow, that really tested my brain there. Well, if you were thinking that I'd invented a new kind of Ruby syntax, then you were wrong. Okay. Maybe this can be the same. Maybe this can be the same deal. So I believe the answers here are 1, 1, 2, 6, 24, 120. That's not 5 times, that's 6 times. Nice. How slow is it? How slow is it? Thanks, Benjamin. Benjamin says, I actually was surprised how the brain can still operate so late. Well, yeah, barely. So 6 is 720. Let's see how far we can go. $5,040. 403.20. 362.880. And then this can be 10 times as well. Great. And then raise and less 10 times map even. And then that will be 0's even, 1 isn't, and so on. 1 0 1 0 1 0 1 0 1. 0. Is that 10? No. I was misled by how long the arrays are in the previous lines, but of course those numbers have more digits. Oh. Oh. These return 44 and 99. That's curious. Okay. That's strange. I thought they returned 0s and 1s, but I was wrong about that. So how does this even work? So these are, hold on. So they're using 44 as true and 99 as false. It looks like. Okay, well that's weird. Well, it's not even that, is it? I guess they're not even really supposed to be predicates. I mean, I don't entirely understand what the thinking is here, but obviously what they wanted to do was just test that mutually recursive functions work properly, and we can see here that they do. Yeah, I mean, you know, obviously these are sort of slightly overplayed examples of functions, but I think this would be, if I was going to stick something in the README, I think being able to show like, oh, you know, Fibonacci works, you know, you can call that from Ruby, I think is sort of better than nothing. Add some slightly more interesting function example functions. And I'll say these are from call.wast. I don't think the even and odd result values mean anything beyond demonstrating two mutually recursive functions. Okay. I think I'm probably going to leave it there because I've sort of demonstrated a sort of COD API here that we can use to load a module and then call methods on it. And I've demonstrated that we can do the type conversion. And the only problem is that the internals of that thing is absolutely horrible. So I'm happy to leave it at that point. Let me just run all of the tests to make sure I haven't broken anything. But assuming nothing's broken, then I think next time And I'm going to have a think about using GNU Parallel and see whether there's an easy way to reliably get more speed out just by running, maybe parallelizing this more than it was. And yeah, more importantly, I'm going to think about the design of what the interpreter should look like and actually start pulling it to pieces and rearranging it so that it is a bit less embarrassing what we have to do to implement that API that I've come up with. This is taking a while, isn't it? But I think it's going to succeed because I haven't changed anything. Oops. Okay, typo. Come on, tests. Nearly there. Should have used parallel. Oh, it really takes a long time to run these. Okay, well, the next thing that's going to happen is that we wait for them to run again. This time on GitHub. Okay. This is slightly less unpleasant because it's not in the parent directory on GitHub Actions. I can't even really remember how I set this up. Right, it just checks it out into this spec. Oh right, it like puts them next to each other. Yeah, okay. Right, so checks one of them out into Wasmin and the other one into spec. Okay, that makes sense. Okay, well, this is looking hopeful, isn't it? I wonder if there's anything low-hanging, apart from parallelizing this, I wonder if there's anything low-hanging that I can do to get it running any faster without having to completely rethink how everything works, because it is pretty slow. I mean, maybe I should profile this to understand where all the time is going, and then at least I'll know what I'm supposed to be tuning. All right, looks good. Okay, well, as I said, I'm pretty sleepy, so I'm gonna stop there. Yeah, I think that was, nowhere near as much progress made this time, mostly faffing about, but I have at least started to think about what I want that public API to look like, and that's helping me to think about what the deficiencies in my current design are. You're welcome for the void, Benjamin. I'm glad you're enjoying the formless void. But yeah, I'll wrap up for now. So I won't say anything because my magic button's not working. There we go. I'll say bye. Thanks very much for watching. As always, I really appreciate the time and the attention, and I'm sorry it's not always super interesting, but this is what it is. So thank you for tolerating what it is. I'll see you again soon, next time. Thanks a lot. Bye.